Welcome back, everyone. In this video, we're going to do lessons 4 and 5, go through lessons 4 and 5 of Unit 3. And this, again, is going to be a continuation of yesterday's lessons where we started learning about fractional exponents. All right, this is what we learned about in the previous lesson. Okay, so if I have a power of 1/2, that is the same as square rooting. A power of 1/3 is the same as cube rooting. A power of 1/4 is the same as fourth rooting, so on and so forth. While that is an interesting rule, that doesn't address the case of what happens if the numerator is anything other than 1. So the stuff we learned in the previous lesson only covers 1/2, 1/3, 1/4, 1/5, so on and so forth. Well, what if I have an exponent of 2/3 or 3/4 or 3/5? Well, this is going to cover that. This is going to cover the cases like that, the fractional exponent rule. So it turns out the denominator will still tell me the root. So just like up here, when the denominator is 2, it was a square root. The denominator is 3, it's a cube root. It's going to be the same over here. So the denominator of the fraction will tell me the type of root that we're using, whether it's square, cube, fourth root, fifth root, so on and so forth. The numerator of the fraction will tell me the exponent. So see, the numerator will tell me the exponent, but the key is the exponent can either go inside the root or it can go outside the root. It does not matter. They mean the same thing. So again, the denominator tells me the root, and the numerator tells me the exponent, which can go inside or outside the root. So with that in mind, let's go to the examples for this lesson. So let's fill in the following table and see how this works. So our first row here, these are going to be our x values. These are going to be our x values right here. And we're going to plug in these values for x. So we're going to write 5 to the power of x using exponents. So in this case, it's going to be 5 to the power of 0, 5 to the power of 1/3, 5 to the power of 2/3, 5 to the power of 1. Okay, we can keep going. This row is pretty easy to fill in. 5 to the power of 4/3, 5 to the power of 5/3, and 5 squared. Okay. In the second row, we're going to write an equivalent expression to what we wrote in the first row. That might involve writing it in radical notation. Radical notation means using roots. So that might mean using roots. That might mean just calculating the answer. So for this one, 5 to the power of 0, I talked about this in the last video. Anything to the power of 0 is 1. Okay? 5 to the power of 1/3. Okay, we talked about this also in yesterday's video. Anything to the power of 1/3 is the same as cube rooting that thing. So this is going to be the cube root of 5. And the cube root of 5 is not a perfect cube, so we'll leave it like this. Okay. This next one is where today's lesson comes in. So 5 to the power of 2/3. So if I'm going to write it using radicals or roots, so I'm going to set it up that way. Okay. The denominator of the fraction tells me the root. So the denominator being 3 tells me this is going to be a cube root. Okay. The numerator tells me the exponent. So that could be written like that. So the cube root of 5 squared. Okay. Well, I could also write that as the cube root of 25. How do you think I got 25? Well, 5 squared is equal to 25. So 5 to the power of 2/3 is the same as the cube root of 5 squared or the cube root of 25. Okay? 5 to the power of 1. Well, that's easy. That's 5. Okay? 5 to the power of 4/3. So using the same thing as before, if I'm writing this with radicals or roots, the denominator of 3 tells me it's a cube root, and the numerator of 4 tells me it's going to be the cube root of 5 to the power of 4. And if I calculate that, okay, I can write that as the cube root of 625. How did I get 625? Well, 5 to the power of 4 is 625. Okay. 5 to the power of 5/3. So this is going to be the same thing. All right. It's still going to be cube root because of the denominator, but now it's going to be the cube root of 5 to the 5th. 5 to the power of 5, which could also be equivalent to the cube root of 3,125. And again, how did I get that? 5 to the 5th is 3,125. Okay. Last one in the table, 5 squared. That's easy. That's 25. We should know that already. Okay. Let's look at the next set of examples. Okay. Let's look at the next set of examples. So this is partially filled in already because we did this in the last, we did 0 1/3 in the last table. But if I were to plug in -1/3 and make this 5 to the power of -1/3, I talked about this in a previous video. 5 to the power of -1/3 is the same as 1 over 5 to the power of +1/3. And we should know that 5 to the power of +1/3 is the cube root of 5. So we should know that that is equivalent to the cube root of 5. So 5 to the -1/3 is the same as 1 over the cube root of 5. Okay? Either one of these works. Okay? 2/3, again, we did in the last table. So if I made that a -2/3, that same rule is going to apply here. Okay? So 5 to the power of -2/3 is going to be 1 over 5 to the power of 1 over 5 to the power of +2/3. And we figured out that 5 to the power of 2/3, this is going to be 1 over the cube root of 5 squared. I got that from over here. And I could further simplify that as 1 over the cube root of 25. Again, 5 squared is 25. So 5 to the power of -2/3 is the same as 1 over the cube root of 25. And 25 is not a perfect cube, so I'll leave it like that. Okay? 5 to the power of 1 we already did. If I have 5 to the power of -1, that's going to be 1 over 5 to the +1. And we know that 5 to the +1 is 5. So 5 to the power of -1 is equivalent to 1/5. Okay? So to reiterate, the purpose of this lesson was to introduce fractional exponents where the numerator can be anything. It could be 1, it could be any number. Okay, and the key is the denominator of the fractional exponent tells you the root. The numerator of the fractional exponent tells you the actual exponent. And that could, again, go inside or outside the root. And that is it for this lesson.